Hey guys, so today's topic is Apache Kafka. Kafka is a distributed messaging system. Before starting, let's look at the scenario. At minimum, there may be only two systems, source system and a target system exchanging data with data pipeline. So managing a single data pipeline is quite simple, right? But in an application, when we have more number of systems exchanging data, then it becomes very complex to manage all the data pipelines, and here Kafka comes into picture. Kafka is a distributed publish subscribe messaging system, an open source software which provides a framework for storing, reading and analyzing streaming data. So it is a distributed streaming platform for processing large volumes of streaming data for real-time application. It was originally developed at LinkedIn and later on became a part of Apache project. Kafka is used to build real-time streaming data pipelines and real-time streaming applications. It was originally designed to track the behavior of visitors to a large and busy websites, and LinkedIn was one of them. So here is the Kafka workflow orchestration, and these are the components of Kafka. Let's say producer, consumer, broker, topic, partitions. We will be looking at all the components of Kafka one by one. So first one is topic. A topic is a category name to which messages are published and from which consumers can receive messages. Brokers in Kafka, the cluster usually contains multiple nodes. They are known as brokers and maintains load balances. A broker receives messages from producers and consumers and fetches messages from the broker by topic, partitions and offset. Next is consumer and consumer group. Consumers are the recipients who receives messages from Kafka server, and consumer group in Kafka refers to a number of consumers that pull data from the same topic or same set of topics. Next is producer. A producer is a client that sends messages to Kafka server to the specified topic. Partitions. Topics in Kafka are divided into a configurable number of parts, which are known as partitions. Partitions allow several consumers to read data from a particular topic in parallel. Partition offset. Messages or records in a Kafka are assigned to a partition. To specify the position of the records within the partition, each record is provided with an offset. Replicas. Copies of the partitions are known as replicas. Replicas are like backups of the partitions in Kafka. They are used to ensure that there are no data loss in the event of failure or a plant shutdown. Leaders and follower. Every partition in Kafka will have one server that plays the role of a leader for that particular partition. The leader is responsible for performing all the read and write tasks for that partition. Each partition can have 0 or more followers. The duty of the follower is to replicate the data of the leader when leader is unavailable. And these are Kafka APIs: producer API, consumer API, connector API, streams API, and admin API. Producer API permits an application to publish streams of records. Consumer APIs permits an application to subscribe to topics and process the streaming of records. Connector APIs executes the reusable producer and consumer APIs that can link the topic to an existing application. Stream APIs. This is an API converts the input stream to output and produces the result. In admin API is used to manage Kafka topics, brokers and other Kafka objects. Minimum system requirements to run Kafka. So minimum we require memory, CPU, text storage size and network. So for Kafka, minimum memory required is 8 GB. It's 6 GB, but we have few more configurations, so it takes almost 8 GB. But it's for CPU we need 4 cores and 500 GB disk storage and 1 GB Ethernet to 10 GB Ethernet network. So these are the minimum requirements to run Kafka. Moving next, we have some steps to run Kafka. Firstly, we need installations and setup for Kafka. Then we need to configure topics using curl commands, and then we need to configure our producer and consumers. Here is a code snippet where it shows all the producer configurations which we need to put, and next for consumer same as producer. Then we have Kafka producer service and Kafka consumer service. Here we need a listener and publisher for publishing messages and for receiving messages. So next is why Kafka is used. So it has a lot of advantages. First one is scalability. Kafka has a distributed architecture capable of handling incoming messages with higher volume and velocity. Next is high throughput. Kafka is able to handle thousands of messages per second, so messages coming in at a high volume or a high velocity or both will not affect the performance of Kafka. Next is low latency. Low latency refers to the amount of time taken for a system to process a single event. Kafka offers a very low latency, which is as low as 10 milliseconds. Next is fault tolerance. By using replication, Kafka can handle failures at nodes in a cluster without any data loss. Next is reliability. Kafka is a distributed platform with a very high fault tolerance, making it a very reliable system to use. Next is durability. Data present on a Kafka cluster is allowed to remain persistent more on the cluster than on the disk. This ensures that Kafka's data remains durable. Next is Kafka use cases. So we have following Kafka use cases here. First is message broker. Kafka serves as an excellent replacement for traditional messaging brokers. Compared to traditional messaging brokers, Apache Kafka provides better throughput and is capable of handling a larger volume of messages. Kafka can be used as a publish subscribe messaging service and is a good tool for large scale messaging processing application. Next is tracking website activities. The activity associated with a website that includes metrics like page views, searches, and all actions that users take is published to a centralized topic, which in turn contains a topic for each type of activity. This data can be further used for real-time processing and real-time monitoring. Next is monitor metrics. Kafka finds applications in monitoring the metrics associated with operational data. Statistics from distributed applications are consolidated into centralized feeds to monitor their metrics. Next is stream processing. A widespread use case for Kafka is to process data in processing pipelines, where raw data is consumed from topics and then further processed or transformed into a new topic or topics that will be consumed for another round of processing. This processing pipelines create channels of real-time data. Next is event sourcing. Event sourcing refers to an application design that involves logging state changes as a sequence of record ordered based on the time. Kafka's ability to store large logs make it a great choice for event sourcing applications. Last is logging. Kafka can be used as an external commit log for a distributed application. Here are drawbacks of Kafka. Tweaking messages in Kafka results in performance issues. Kafka is well suited for cases where the messages does not have to be changed. Next is in Kafka, there is no support of wildcard topic selection. So it should be, topic name should exactly match with the topic name provided. Certain message paradigms such as point-to-point queues and request reply features are not supported by Kafka. Large messages require compression and decompression of messages. This results in an effect on throughput and performance of Kafka. Next, questions and answers. Let's know in the comment section below what queries you have, and we'll see you in the next video with some code changes and running Kafka on our local machines. Thank you guys. Thanks for watching.